Hi everyone, my name is Satyaam Raha. Welcome back. So in this video, let us learn about the bias variance trade-off or the overfitting and underfitting trade-off concept in deep learning. So we have already seen it in machine learning. So let us do it for deep learning concept. So you can see in deep learning, we'll have a certain number of layers, right? So more the number of layers, we'll have more number of weights to tune, right? And obviously, when we'll have more number of weights, what will happen? My model will tend to overfit. Yes, and that will result in high variance problem. Okay, that is my model is varying so much with the data. If a data changes a little, my model will change to a greater level, exponential level. That is why high variance is related to overfitting. Okay, make it a mapping in your mind. Whenever there is overfitting, it is called high variance. Whenever there is underfitting, it is high bias. Okay, so remember this. Now in case of let us say one layer, let us say we have a single layer, very less layer, what will happen? Very less number of weights, right? If less number of weights, so we'll have higher chances of underfitting, right? This is the problem. And high chances of underfitting means high bias. So just remember this relation. Overfitting is related to higher variance, high variance, and underfitting is related to high bias. We need to minimize variance, and our model ideally should not have high variance, okay, and it should not have high bias. That is why we need to find out. But in MLPs, normally we see the problem of overfitting, okay. We normally do not see underfit much because the number of layers will be more normally in case of neural networks. So obviously we do not have much problem with underfitting. Normally we don't underfit, but obviously since the we use very huge number of layers normally, our models tend to overfit. Okay, so we need to solve it. How do we solve it? So we can solve it using the traditional solution, regularization, right? So let us say our model or the optimization formulation is let's say whatever the loss is, okay, loss of yi and yi hat, the prediction. Along with that, we need to minimize it, right? Normally we need to minimize it. So along with that, if we add a regularization term, we have seen it in various machine learning algorithms already. So we could, let's say, the weights, right? We could do like this. Let us say ijk, and depending on the regularization we use, this is for L2 regularization. Okay, we also know we can use L1 regularization. So in case of L1 regularization, what will happen? We'll create some sparsity in our weight vector, right? So we can use it. Either we can use L1 regularization, we can use L2 regularization. Doesn't matter. This is basically the parameter, hyperparameter, right? So if it increases, if we increase the value of lambda, what will happen? Our model will tend to not overfit. Okay, the overfit will actually decrease. That is how we can control overfitting. Underfitting is not very relevant in case of deep learning, but yes, using regularization we can simply boil down the overfitting problem. Okay, this is what we can do. We can also use L1 regularizer, as I said. Now obviously lambda, if it increases, the variance will decrease, so overfitting will decrease. And number of layers also, if we if we see our model is very much overfitting, what we can do is we can decrease the number of layers. Okay, that will also decrease the variance, and that will decrease the problem of overfitting. So this is how you can visualize bias variance trade-off or underfit overfit trade-off in case of deep learning. Okay, in the next video we'll see a very elegant concept which is actually used in in the current era, that is something called as a dropout concept. It is a very elegant concept, and obviously regularization is more of a machine learning concept. It is a traditional concept, but nowadays dropouts are used almost everywhere. Okay, so that's it for this video. Maybe in the next video I'll see you guys with dropout concept. Okay, so thank you for watching. Bye.